Hello everyone, welcome to the fourth video on IT tutorial. In the last video, we saw this module called the OS module that allowed us to interface with the operating system in which we were running our Python program, right? So in this video, we are going to look at yet another module. This module is called NumPy, and this is a very popular and a very important module in Python. So with this module, what we can do is we can handle arrays and multidimensional arrays. Okay, like two-dimensional array would be called a matrix. So those kind of multidimensional and single-dimensional array we can handle using NumPy. Now you might be asking that we have already studied about list, right? There is a data structure in Python called list. So in spite of having list, why is it that we are learning about this one more module? Why do we have this module to work with arrays? Right. So the reason is that Python list, as I already explained in your class, all these elements of list are not continuously in the same memory. Right? There is no locality of reference. So what is happening? Your say index 0 will be in some place in memory, index 1 will be in some other place. Now in NumPy, all these indices, all these values would be continuous like it is continuous in languages like C. Okay. So above that, this NumPy is written using C++, and because of this continuous memory location, what will happen is that when we are going to use this array, we usually use, if we are using this index called I, it is very normal that we will be using I plus 1 or I minus 1 index in the next iteration, right? This is called locality of reference. Now what is going to happen is that your array, okay, it will be in RAM, but when executing, when using your array, your processor will be required to bring this array from RAM to your cache memory. So if your array, all these nearby indices, if they are together in cache memory, it will be very easy, it will be faster for the processor to access them, right? So because of this, NumPy works faster than our list, and we will be looking at this practically once we start using this NumPy. Okay, so with that, let us start. I am going to use collab. So the first thing that we are going to do is import NumPy. Okay, so this is the statement that we use. This is the exact same statement that we use to import OS. So if I import NumPy, then in order to access some attribute of NumPy, I will be writing numpy dot, say I have this attribute underscore version underscore. So let me connect to my runtime. My runtime is connecting. Alright, it takes some time. It takes more time when I need it to connect faster, right? Okay, initializing, it's almost done. Okay, connected. So yeah, I have imported NumPy. I am printing the version of the NumPy that I have installed in my cloud system in this Google Collaboratory, right? So see, whenever I try to access this NumPy module, I will have to write NumPy in front of every attribute or every method. So this, unlike OS, which has had only 2 characters, this NumPy has 5 characters. So we are going to shorten it. 5 characters is too long for us, right? So we are going to shorten it to NP. Okay. Now when I access NumPy, I will just be writing np.attribute name or np.method name. So let me run this again. Done. Okay. Next, let us create an array using NumPy. Okay. So this is my line of code. I am going to name it ARR. What I am going to say is nempy dot array. This is the dot array is the method that is going to create an array for us. Inside this dot array, we are going to give, say we are going to create a array with 3 elements, 1, 2, 3. Okay, that's all. 1, 2, 3. We are going to create an array with 1, 2, 3. Let me give 1, 2, 3, and let me see what happens. Okay, so it says that there is some kind of an error. Okay, so it is a value error. What does it say? It says that only 2 non-keywords arguments are accepted. So what do I do? Alright. The error is because of the fact that when I try to create a NumPy array, I will have to pass these elements that I want to create using a list or a tuple. So previously I had written the elements directly. I had given the elements directly as a parameter to this array method. Now I am not passing the elements directly, I am passing a list. This is a list that I am passing. So let us see what happens. Yes, it has executed correctly. Let me print this array. Alright, and let me print the type of this array. Alright, so yeah, let's go ahead and see what is the output. Yeah, it says, it prints the array as expected, and it says that the class of the array is numpy.ndArray, n-dimensional array. So this is the class type. This is the type of arrays in NumPy. So previously when we created array using list, we got the type as list, class list. Now we are getting the class as numpy.ndArray. Okay. Now let me make some manipulation in order to show you some other, the same thing. I am going to do the same thing, but let me write this. My list is the variable that stores the list, and in this np.array I am going to pass this variable called my list. So once again I am going to get the exact same thing. Just understand what I have changed. Previously I had written the array directly in here. Now I am passing that array, sorry, list, not an array. I had written the list directly in here. Now I am passing the list as a using a variable, right? So nothing is going to change, and as expected nothing has changed. Alright, so I had passed a list. Instead I can pass a tuple as well. I did not change the name of the variable, but then the type had changed. I have passed a tuple, and in the output nothing has changed. I am still getting an ND array. It is still printing the same array. So I can pass a list to this array variable, or I can pass a tuple, right? So what I cannot do is I cannot directly write the elements of this list directly inside this array. I have to pass the elements to a list or to a tuple. Alright, so this is how we create an array. Okay, an ND array, a NumPy's array. Let us now try to create a few more arrays. Okay. We will be using list to create arrays throughout. I won't be using tuple. So let us say this we have already seen, and let us print the type, not a problem. This is a one-dimensional array. Fine. Let us next print array 2-dimensional. So np dot arr. What I'm going to do is I'm going to arr a1. Sorry, I am going to pass a list to here, right? So I will once again be passing a list. Now previously also I passed a list, but the difference between now and the previous 1D case, one-dimensional case, is that now my list, okay, is going to contain list. So it's an array of array, 2-dimensional. You know this already from languages like C. So let me make this 1, 2, 3 and then 4, 5, 6. So I have this. Let me print arr 2-dimensional, arr 2. Okay. Okay, I have to make a spelling mistake. Arr a1. Okay. Yeah. So now see, I have this 2-dimensional array. It's a matrix, right? So in this matrix, what are the rows? What is the column? This I have. How did I create this matrix? How did I create this 2-dimensional array? I passed a list, and that list was a list of list, right? So this would be my row 1. This would be my row 2. Okay, here I can see this is my row 1, this is my row 2. Okay, now let me make a 3-dimensional array. Okay, in my 3-dimensional array, I am going to see, for my first 1-dimensional array, I passed a list. For my second 2-dimensional array, I passed a list of list. Now for my 3-dimensional array, what am I going to do? I am going to pass a list of list, if that makes any sense. Alright. Let me copy this. Okay. So what I am going to do is I will pass a list that will contain 2 lists, and each of these 2 lists are going to contain more lists. Okay, so this, let us say 7, 8, 9, 10, 11, 12. Okay, and let me print them. Okay, here I can see this is my first 2-dimensional array, and this is my second 2-dimensional array. Okay, and those are inside one array. So this final array is a 3-dimensional array. This 2-dimensional array is the first element of my 3-dimensional array. This 2-dimensional array is the second element of my 2-dimensional array. Right? Alright. Now let us look. So this is how I create arrays. Okay. Now there are a few more methods of creating array. You may find this handy often. I am going to create an empty array. Alright. This can be created using np.empty, and then I am going to pass the dimension. Say I pass 3 rows, 2 columns. Right. So let me print this. Alright. So as you can see, I have values in here. I said this is going to be an empty array, but then these are random uninitialized values. Okay, this array is empty. The values that you see in here are random values, so these are meaningless. Don't stress too much about it. Now these you can see are floating point values, right? I can give this d type is equal to int. If I pass the data type and let me run this again, now I see that my array is filled with this empty array is filled with this random integer values. Okay, so this is an empty array. Now sometime I may need my array to be initialized with zeros, so that I can do using 0, and let me make a new array. 0 equal to np dot radros, and now I specify the size. Let me say my size is 5. Okay, let me print this 0 array. So this is the array filled with zeros. This is my single dimension. I specified my size as 5. Instead, let me specify the size with 5, 3. So this is going to be 5 rows, 3 columns. Okay. So yeah, I have 5 rows, 3 columns. So this is how I can make multi-dimensional array of zeros. In the same way, I can make multi-dimensional empty arrays. Again, sometime you may need your array to be initialized completely with ones. Right, so I am going to write np dot ones, and this is going to be in size 3 cross 3 square matrix filled with ones. So yeah, this is a 3 cross 3 square matrix filled with ones. Now see, you can see that each of this element, okay, it's a floating point value. Yeah, it's a floating point value. So if we wanted this to be filled with integers, say I will write type equal to int. Let me run this again. So now it is filled with integer. Once again it is filled with 1. Previously also it was filled with 1, but previously these ones were floats. Now these ones are int. Right? So next we are going to create an identity matrix. So if you remember what is an identity matrix, it is a matrix where all the elements except the diagonal are filled with 0 and the diagonals are filled with 1. So it's a square matrix where all the diagonal elements are filled with 1 and the rest of the matrix is filled with 0. This matrix is important because if you multiply any other matrix with the identity matrix, you will get back that matrix. Or if you multiply the identity matrix with any other matrix, you will get back that matrix. Alright, we will see why this is important later on when we study abstract algebra in discrete maths. What is the meaning of identity matrix and things like that. But let us create the identity matrix over here. Okay? A identity, let me call it A identity. So it's going to be np.identity, okay, and it is going to be a square matrix. That means if there are 5 rows, there will be 5 columns. If there are 3 rows, there are going to be 3 columns. It's going to be square. So there will be the rows and the number of columns are going to be equal. Let me specify that number. Let me say 4. Alright. So let me print this. A_underscore identity. Alright, let me execute it. Alright, we can see here that it's a square matrix 4 by 4 where the diagonals are 1 and everything else is 0. Alright. So this is the identity matrix. So this is one more way of creating matrix. So we have seen this way of creating matrix, one dimensional, two dimensional, three dimensional, okay, by specifying the elements directly. Alright. Then we saw this other way of creating matrix using some special functions that are available in NumPy. So these special functions are used to create some special matrices. For example, the matrix filled with zeros, the matrix filled with 1, some random empty matrix, or the identity matrix. So apart from this, there are more functions to create more special matrix. We will not talk about those in this tutorial. Okay. Next, let us look at one more way of creating matrix. But before we look at that way, one more way of creating this arrays, n-dimensional arrays in NumPy. So before we look at that, let us revisit one concept that we learned in the initial class of this Python programming in this IT tutorial course. What did we learn? We learned that if I write for x in some array, some list, say 1, 2, 4, 3, okay, and I print this x, you know what it is going to print? It is going to print 1, 2, 4 and 3. Okay. So instead of writing 1, 2, 4, 3, I could also write range for x in range 10, for example. So if you remember what x in range 10 is going to do is, it is going to give this x the value from 0 up to 10 minus 1, right? Yeah. But then if you observe clearly, you can see that both of them had the same syntax. So what do you think is the value that is being returned by this range function? Let us print this range function. This range function is returning me some range from 0 to 10, right? It's returning me a list from 0 to 9, not 10. So in the same way, in NumPy, we have this called, let me create an array called np.arange, okay, and let me specify 10 again. So what is this arange going to return? It is similar to our range function in Python. In Python, it returns me from 0 to 9. Here it is going to return me a ND array from 0 to 9. Okay. Now let me make some changes. Let me write 10.0, for example. It is going to return me a list. Now previously I had specified a integer, it returned me integer. Now I am specifying a float, it is returning me a list of floats. In the same way, I can go from 2 to 10, for example, like we did in range. Similarly, in arange also we can specify this start and stop. Okay. In the last call, I did only stop. Now I will specify the starting point and the stopping point. The stopping point, of course, will not be included. So I have from 2 to 9. Again, like in range function, I can specify the step size. So it is going to go from 2 to 8. Next would have been 10, but then 10 is not included. So we go up to 8. Okay. So you can see this is one more way of creating. What is this? This is the, let me print out the type. This is the, what do you think? This is the ND array, right? So this is one more way of creating ND array. So till now, how many ways did we see? We saw this one way using this low level method called array. Then there are some special functions, high level function to create some special types of array. And then we have this range, a range, which once again is going to create an array, but then it is going to go from some start to some stop. There are three what is it called? Signature of this function. Okay, in one signature we just specify the stop point. Okay, then the next signature we specify the start point and the stop point, and in the next signature we specify the start point, the stop point, and the step size. So yeah, these are the different methods of creating arrays in NumPy. Now creating array is done, but we did not still access any elements of this array, right? So that is what we are going to do in the next part. I have this array, array 1. This is a one-dimensional array. Let us say I want to access this 3. Alright, so I will write a__1. How many indexes do you think I have to write here? This is a one-dimensional array, so only one index would be sufficient, the index itself, right? So this would be addressed to using 0. The first element would be addressed using 0, second would be 1. This third element that I want to access would be addressed using 2. So a__1 index 2 is giving me 3. Now let us say in this array, the second array, I want to access this 5. Alright, so how do I access it? This is my second row. Alright, in this is the matrix, this is the second row of the matrix, and I want to access the second element of the second row. That means I want to access the second row, second column. Okay, so in here I will write, in this two-dimensional array I have to specify both row number and column number. So I will be specifying 2 indices. Okay. So I will be, my second row, alright, would have the index 1. My first row has the index 0, second row will have the index 1. So I specify the row first, then the column. So my second column will have the index 1. Using same logic as I applied in case of row. So I wanted to access this 5. I am now able to access this 5. Now let us say I want to access this 5 of this array 3. Array 3 is a 3-dimensional array. Okay, so we go dimension after dimension, right? So here I am going to look at what is the shape of 3. I have an array that contains two-dimensional array, 2 matrices, right? So in my first matrix I am going to go into second row, and in my second row I am going to go into second column, right? So I am going to go into my first matrix indexed by 0, second row indexed by 1, and second column indexed by 1. So this is matrix number, row, column, right? I am once again going to get this one. Okay. Now let us say I had a 4-dimensional array, a 4-dimensional matrix. Now how would I access some element of this 4-dimensional matrix? First, this 4-dimensional matrix is going to consist of several 3-dimensional matrices, right? So I will specify which is the 3-dimensional matrix that contains my element. Say I am accessing from the third, so I will write 2. Okay, my third 3-dimensional matrix. In that 3-dimensional matrix, I am going to get lots of 2-dimensional matrices. So there I will specify which 2-dimensional matrix I want. Then I will specify in that 2-dimensional matrix which row I want, and then in that row I will specify which column I want. So we go from top up to row and then column, right? So from the highest degree, highest dimension on the way to the lowest dimension. In the lowest dimension I have this 1-dimensional rows, and I will get the column from that 1-dimensional rows. Okay. So next, let us look at how to slice an array. Okay. So slicing an array means in these matrices I am going to cut out parts and get only some part of that this entire matrix. So my entire matrix is like a loaf of bread, and I am going to cut out slices from that bread, if that makes any sense. Okay. So before I go ahead with slicing matrices, these matrices are too small for that purpose, so let me increase the size of the matrices. Right? Let me add more elements. It is making more elements 3, 6, 5, 4, 5, 6, 5, 4, 3, 2, 1, and then from here, okay, we will increase the size of that matrix if necessary later. So I have changed this cell. Let me compile this cell. Now what do I want to do? This matrix, okay, I want to say get elements from I don't want this entire 1-dimensional matrix. Say I want from this first position to say 5th position. Okay, this is index 5. Okay, so 1, 2, 1 colon 5. Okay, if I specify 1 comma 5, what will happen? Let us see what will happen. What will happen? Is it going to execute correctly? No, I am going to get an error. I am going to get an index 5 is out of bound. So it is a 1-dimensional matrix, but I am trying to access it as if I am trying to access the 5th column from the 2nd row, but it does not have a 2nd row. It is 1-dimensional, right? So I am going to get an error. Alright. So 1 comma 5 would be wrong. I am going to slice it. I am not trying to access it. I have this entire array. I am going to get from some starting point to some end point. Right? So I am slicing from 1 to 5. Alright, this is not 3. This is 1. Okay. So I am getting from here up to here. Okay. So this end index is not included. Like in case of range, I am specifying that I want from this index. This is my starting index 1. This is my ending index. I have written 5, so I get up to 4. Okay. Now what will happen if I don't specify the starting index? I am going to get from the very beginning up to the whatever I have specified, the one before that, right? So I will get from 1 to 5. Now what if I specify this starting index from 2 and I don't specify the end index? I'm going to get from 2 up to the end. Alright, then yeah, this is very interesting. Let me specify using negative numbers. Be very careful using negative numbers. What am I saying? I am saying that the third element from the end up to the last element I am going to slice, right? So 1, 2, 3, this is the third element from the end, this is my last element, so I am slicing from the third element to the one before the last element. Okay, last element is -1, this is -2, this is -3, so from -3 I am going to slice up to this end before. Like in case of positive number also, when I specified some index in here, the ending index, that was not included. When I specify using negative number, then also it is not included. Okay, now next, yeah, let me slice once again. Let me go back to positive. 1 to 5, we were doing 5. So 1 to 5, what did it give me? It gave me 2 to 5, right? So let me specify the step size now. You know what is the step size? We saw that in range, we saw that in arrange. Okay, so it has given me 2, 3 is skipped, 4, 5 is skipped. Next it would have given me 6, but then 6 is beyond my range, right? Beyond the slice that I have taken. Now I am slicing in step size. Okay, what will happen if I don't specify the starting point, if I don't specify the end point? I will have slices from the beginning to the end in steps of 2. So this is my answer. Beginning, this is ignored, then this is taken, this is ignored, taken, ignored, taken. So yeah, this would be my answer. Alright. Next, let us look at slicing this two-dimensional array. Okay, so I am saying 1 to 4. What is it going to give me? It is going to give me this. This is my 1. This I have taken, right? I have specified that I am going to get this 1, and from this 1 I am going to get this 1. From this 1 index up to this is 4, so I will get this one. Sorry, this is going to give me an error. What is the range? I am saying that I have 2 dimension in this array, but I am still using array 1. I have to specify array 2 here. So yeah, so I have 5, 6 and then 3 as expected. Now let us say okay, this array has 2 rows, right? Let me create one more row, otherwise it becomes too small. The array is too small for any practical purpose. Okay. Now I have this array with 3 rows, right? So let us say, what was I doing? I took this. Let me run this again to show that the output is not going to change. Okay, as expected, I had taken what? I had taken this index 1 row, then column. What I had taken? I had taken 1 to up to 4. 4 was not included. So from index 1 to index 3 I had taken. So this was my answer. Now let us say I want to take from this from these 2. Okay, so I am going to slice from 0 up to 2. So when I say 2, I am going to get this 0 and 1. So I am going to get this row and this row. Okay, so I will not get this row because this I have not taken. I have said 2, so I will get this 0th row and this first row. In the column, in the row field, I have specified that I want 0 and 1. So from 0 to 2, but then 2 is not included. These are the rows that I want. These are the columns that I want. I want the 1, 2, 3 column of this row. I want the 1, 2, 3 column of this row. So let me run and see what is going to. Sorry, not that. I should have done this. Let me run and see. Yeah, I got this 2, 3, 6 from this row and this 5, 6, 3 from the second row. Alright. So this is how we can slice an array. Let me show one more slicing. Let me say I want to get from 1 up till the end. Okay, from this up to the end, and I want only the 4th element, right? So I am slicing, but I am getting only 1 element from this column. So what are the rows? Rows are from this 1 and this 2, from 1 up to the end. So this 2 will be taken. And what is the column that will be taken? 0, 1, 2, 3, 4, this 2 and 5. Yeah. So I got this 2 and 5. Okay. So I hope you understood slicing. So this is all about slicing that you need to know right now. Had this been a 3-dimensional matrix, so I have a 3-dimensional matrix. This is too small. Let us not go into 3-dimensional. You do it on your own. Okay, take that as a homework. Create a 3-dimensional matrix and try to slice it. So what is a 3-dimensional matrix once again? It is an array that contains 2-dimensional array. So that is a 3-dimensional array, right? So in that array of 2-dimensional array, you can slice that array as well, like we sliced columns and rows over here. So that array of 2-dimensional array would be indexed by the first index, then the rows of the 2-dimensional array inside those array of 2-dimensional array would be indexed by the second index, and finally the column of those rows would be indexed by the last index, right? So yeah, do that. Alright, don't ignore. Create 3-dimensional array. Create a large 3-dimensional array, okay, having like three 2-dimensional matrices, and try to slice those matrices. Okay. Next, let us look at a very important this attribute of these objects, this ND array objects. Okay. So what is the type of array? The type of array is ND array. We saw that already. Let us look at an important attribute. This attribute is called shape. It is going to give us, as you might have guessed, the shape of the array. Okay. So let us see what does array 1. What is the shape of this array? It says the shape is 7. There is only one variable in here. It is 7. So what does that mean? It means that there are 7 elements in this array, 1-dimensional array. Okay. Let us look at the shape of 2. It says 3, 6. That means in the higher dimension I have 3 elements, right? So this is one element, this is one element, and this is one element. And then in each of these means in the lower dimension I have a maximum of 6 elements. So 1 2 3 4 5 6, each of them has 6 elements, right? So in case of two-dimensional array, it means that there are 3 rows and 6 columns. Okay. Now make a guess what is going to happen when I print the shape of this thing. Okay. So what is the highest dimension? In the highest dimension, if I look at it, what is this thing? This is the array of two-dimensional array, right? So this array of two-dimensional array, how many two-dimensional arrays are in there? That is going to be my highest dimension. Okay, if I had a 4-dimensional array, what is the highest dimension that I will be looking at? A 4-dimensional array would be an array of 3-dimensional arrays. So how many 3-dimensional arrays do I have? That would be addressed by the highest dimension. So in this array 3, how many 2-dimensional array do I have? That is my highest dimension. Then in each of the array, 2-dimensional array, how many rows do I have? Right? And then after that I am going to get each of the row, how many columns do I have? And I am going to get the maximum value out of this. So yeah, what do I see in here? I have two-dimensional array. Each of this two-dimensional array at the very maximum, it has 2 rows. Each of this row has, the longest row that would be there has 3 columns. Okay. So this is all about shape. Now there is a very important function. It is called reshape. Let us look at that next. Alright. So yeah, let me convert this to, let me add one more element. Okay. Now what do I have? I have so I change this. Let me run this again. Alright. What is ARR1? ARR1 is a 1-dimensional array, right? So I want to convert it to a 2-dimensional array. Okay. So what I am going to do is my ARR, I am going to convert it and store it into ARR. Okay. So ARR, I am going to reshape ARR1. My array 1, this 1-dimensional array, I am going to reshape it. So I am going to reshape it into a 2-dimensional array with say 2 rows and 4 columns. Okay. Let me print this new array and let me print the shape of the new array. Alright, let's go. Alright, so see, now I have this new array. This is the array of 2 rows. Each of them have 4 columns. So I have reshaped this 1-dimensional array into a 2-dimensional array. Let me make some changes. I am going to create, what did I do? I made it into a 2-row 4 column. Now let me do a 4 column 2 rows. Okay. So yeah, now it has 4 column 2 rows. Look at the output as well as keep looking at the output of this dot shape attribute. Okay. So let us now convert it into a 3-dimensional array. This I have 8 elements, so I am going to convert it into 3-dimensional array, right? So this 3-dimensional array is going to be composed of 2-dimensional arrays of size 2 by 2. Okay, so 4 elements will be in the first matrix, 4 elements will be in the second matrix. So let's go ahead. Yeah. So now I can see this is my first matrix, this is my second matrix, and this is the three-dimensional matrix, three-dimensional, it's a matrix, not a problem, containing these two-dimensional matrices, right? And this is my shape. Let me try to do one thing. Let me try to convert this into a 3 cross 3 two-dimensional matrix. Alright, what do you think is going to happen? I have 8 elements in this one-dimensional array, right? And that I am going to change into what? A 3 by 3 matrix. A 3 by 3 matrix has 9 elements, but my original array had 8 elements. What do you think is going to happen? So those who thought I am going to get an error, yes, you are correct. What is the error? Cannot reshape array of size 8 into shape 3 cross 3. So if you are going to reshape, make sure that the number of elements that you have fits, right? So this one-dimensional array, let me do one more thing. 10, 11, 12. Let me convert this into a 3-dimensional array with 2 cross 2 matrix. Each of them will have 3 rows, and each of those rows will have 2 columns, right? So, alright, I did not run this cell. Okay. Alright, so yeah, as expected, this is my output. Okay, now let me do one thing. I have reshaped this two-dimensional array into reshape this one-dimensional array into two-dimensional array and three-dimensional array. Let me try to reshape this three-dimensional array into two-dimensional arrays. Okay, I have how many elements in here? I have 12 elements in here. So I can convert it into a 3 cross 4 matrix. Done. I have converted this three-dimensional array into a two-dimensional array. I have reshaped this 3D matrix into a 2D matrix, right? I can convert it into 4 cross 3 or anything, 2 cross 6. Just I have to make sure that my two-dimensional matrix, that the matrix I am going to convert it to, should be able to accommodate all these elements. There should not be a mismatch, right? So yeah, let me run this. I am getting this 2 rows, 6 column everywhere. Alright. Now the last thing in reshape. Let us say I want to flatten this matrix, alright, this 3D matrix or this 2D matrix. I want to convert it into a 1D matrix. I can just specify this -1 in here. I run this. Now I am getting a 1D matrix out of this 3D matrix. I can take this 2D matrix as well, run this reshape, and it will be converted into a 1D matrix. Now this is one method of converting a 2D matrix into a multi-dimensional matrix into a single dimensional matrix. Alright, reshape using this parameter -1. Apart from this, you have a method called flatten that will flatten an array into a one-dimensional array, any multi-dimensional array into a one-dimensional array. And then you have another method called ravel, R-A-V-E-L. So that is one more method. Alright, so yeah, you will very often see this ravel or flatten being used, alright, somewhere else. Let me digress and go back to the beginning of the lecture and say one more thing. I cannot stress enough about the importance of NumPy. Alright, if you later on do data science using Python, you will most probably use this library called pandas. Okay, this pandas library is used to read CSV or Excel file into a format, and that would be later on given to your data science module, whatever you use, scikit-learn or be it TensorFlow. Alright, so before you use this scikit-learn or TensorFlow, you will be reading some CSV file, for example, say, or you will be reading some Excel file, whatever. So you will be reading this file and converting into some array, right? And then you will work on those array using these libraries like scikit-learn or TensorFlow. Now this pandas that you will most probably use is made using NumPy. NumPy is the foundation on which pandas is built. So if you are familiar with NumPy, you will be able to use pandas more efficiently. Alright, you will in many of the cases you will be required to use NumPy modules. For example, let us say you have read some multidimensional array. You will be required to flatten that array, okay, for some algorithm. So you will have to use methods like flatten or revel before you can use the methods for these algorithms. Alright, so yeah, NumPy, understanding of NumPy is going to help you understand pandas if you are going to use pandas to do this machine learning data analysis kind of things. Okay. So yeah, that was one more motivation behind learning NumPy. Should have given the motivation in the very beginning of the class, but then I forgot. Okay. Let us go to the next topic. In the next topic, we are going to look at this concept of filtering an array. Okay. So let us say I have this array. Let me call it A once again. And this array consists of these integers 40, 41, 42 and 43, 44, 45. Okay. And then I have another array. Let me call it F for filter. Okay. And I am saying true, false, false, true, true. So observe one thing. Okay. Observe one thing. This array has 6 elements. This array also has 6 elements. This is an array of Boolean values, right? This is the array with integer. This is the array with true false Boolean values. Now what will happen if I do this ARR and as a parameter I pass this F? Let me print it. Okay, what is the array? Okay, sorry, this is not a normal array. This has to be NumPy array. My mistake. So what is happening? See, from this array, this is the array of length 6. I am getting the array of length 4. So what are the elements from this array that are being taken? Only the elements that corresponds to true. For example, first element in my this index, I have passed this array of Boolean values. So first element is true. I am getting the first element. Second element is false. I am not getting the second element, 41. Third element is false. I am not getting it. 42 is not there. Fourth element, fifth and sixth are true. So I am getting this fourth, fifth and sixth over here. Okay. So this is how you can filter an array. Okay. Now there is one more method of filtering an array. Let me I have created this Boolean array, menu array, right? I can create this Boolean array using condition. For example, I write a double r greater than, say, 42. Okay, and I am going to print this f. Okay, let me run this. So yeah, what am I getting? This f is what? This f is a array of Boolean values, and for each of them, is 41 greater than 42? False. No. Is 40 greater than 42? No. Is 41 greater than 42? No. Is 42 greater than 42? No. Is 43 greater than 42? Yeah. Similarly for 44 and 45, they are greater than 42. So this array of Boolean values I have made using some condition, right? So I am filtering that using this new Boolean array that I have created. So using this is one more way of filtering using some condition. Now I can write this directly in here, not a problem. Okay, I'm going to get the same output, 43, 44, 45. These are the values that are greater than 42. Okay, now you can pause this video and try to figure out what is the, this is a array of Boolean values, right? We have seen that. So similarly, can we pass any array of Boolean values? Can we pass any condition checking that will give me an array, okay, of a filtering array, that when I apply here, I will get only the even numbers. Okay, I want to filter out the odd number. So pause this video and try for yourself. Think about it. I hope you have tried. Now let me do. I am going to do this a double r modulo 2. Alright. So a double r modulo 2, if it is equal to 0, we know it's a even number, I will get a true. If it's a false, I will get a false. Now a double r modulo 2, is this itself a condition checking? This is not a condition checking, this is an arithmetic operation. This, when I equalize, when I try to find out if it is equal to 0, that is a condition check. Alright. So true false value I get out of a condition check, I don't get out of a arithmetic operation. So bear that in mind. Let me now run this. Okay, now I am getting 40, 41 is the odd number, 42 is even, 43 is the odd number, 44 is even, 45 is odd number. So I am getting 40, 42, 44. Alright, as expected. Those of you who were able to do this, very good. Those of you who were not able to do this, I would not say bad, just write, change it, print all the odd numbers. I hope you will be able to do it now. And then don't worry. We always make mistake in the first time. Being complacent with mistake, that is bad. We should try to learn from our mistake. Just sitting back and saying, oh, I make mistake, I am not good enough, I will keep making mistake, that is bad. Okay. We make mistake in the beginning, then we learn, we try hard, we work hard, and then we stop making those mistakes over and over again. Okay. So up till now, what are the things that we learned? We learned what is NumPy, how to create arrays in NumPy, several methods, the low level array function call, then some special method to create some special arrays like array of 0, array of 1, identity, some empty array. Then we saw how to figure out what are the dimensions of array. Okay, one more method of creating array was using arrange. Then we saw how to index these arrays, how to slice an array, okay, how to get the shape of an array and how to reshape an array to a different shape. Okay. Then finally we saw how to filter an array. Now we have created lots of array. Let us now learn how to work with array. Okay. First thing, let me create another thing. I am going to create A and B, two arrays. I am not going to do major operation over here. np.array. Okay. Let me say my first array consists of 1, 2, 3. My second array np.array, it consists of the elements 3, 4, 5. Okay. So first thing first that I am going to do is add this array. np.add. So I am going to pass this A and B that I am going to add. I am going to pass them over here. Then print. I want to subtract np.subtrct. I am going to subtract B minus A. Then I am going to print. I am going to do this multiply. Okay. A into B. Then print. Divide. I am going to divide B by A. Okay. And when I divide, I am going to get some reminder, right? So I am going to do mod BA. And then I have this one more that I am going to show, np.power. This is going to give, say A, I am going to rise to the power of 3. Okay. So yeah, let me run this. I have made some mistake. To subtract subtracp. Okay. Multiply ply. Alright. So add A and B. I am going to get 1 plus 3, 4, 2 plus 4, 6, 3 plus 5, this. Then subtract, I am going to 3 minus 1, I did B minus A. So 3 minus 1, 4 minus 2, 5 minus 3, all of them is equal to 2. Multiply, 3 into 1 is 3, 4 into 2 is 8, this is 15. Then divide B by A, I am getting 3. This is 4 divided by 2 is 2. 5 divided by 3 is 1.66. 6 will continue. Then mod. 3 divided by 1 is going to give me 0. I have no reminder. 4 divided by 2, once again no reminder. 5 divided by 3, I am going to get a reminder of 2. Then power. A 1 to the power 3 is 3, 2 to the power 3 is 8, 3 to the power 3 is 27. So this is what it is. Now this is operation on 2 one-dimensional array. Right? Let me do this operation on this 2-dimensional array with a 1-dimensional array. So let me run this. Okay. This should not contain that thing. Okay, sorry. This was a syntax mistake in creating the array. Okay. Okay. Now what is happening? A minus b, right? So first is a plus b. I am going to add this to both this array. Alright. Then subtract, I am going to subtract from this both of them. So this is the result of my addition. Okay. This is the result of my addition. This is the result of my subtraction. Okay. This is the result of multiplication. Understand this. I am adding element wise. Alright. Even in one dimensional case, I forgot to mention, when I write this multiply, this is not matrix multiplication. Alright. This is element wise multiplication. So first element will be multiplied with second element and so on. So addition, what is happening? You can imagine that this is being repeated. Okay, this is a one dimensional, so it is made into two dimensional, and then we are adding. So this is added to this, we get this row. This is again added to the second row, and we get this row. Then subtraction from b minus a. From this I am subtracting this, I am getting this. From this I am subtracting this, I am getting this. Alright. So multiply a into b. So with this I am multiplying element wise this, I am getting this row. With this I am multiplying this, I am getting this row. Okay. So together for two of them I am getting this 2D matrix. Similarly, this is the result of division. This is the result of that division, the modulo of that division. Alright. And this is the result of this power. Okay. So I have 1 square, 2 square, 3 square, 4 square, 5 square, 6 square. So yeah, this is a lot about, this is a few things about, not a lot. This is a few things about arithmetic operation, right? First we saw between two one-dimensional array, then we saw between a two-dimensional array and a one-dimensional array. So let us proceed to the next topic. Next is rounding function. Let us say I have this array, NP array, and it consists of several floating point values 2.3.2, 3, 4, 10, 7.66, then 9.89, 98, whatever, 6.66, the number of the base. Alright, now this is the NP array. I am going to do a few things that can be done. NP dot round, I can round it to the nearest integer. Alright, then I can get the floor of this, round it to the smallest nearest integer that is smaller than that, round it to the integer which is rounded to the greatest integer that is smaller than this. Okay, that is the definition of floor that we studied in discrete maths. Okay. I have been touching my hands too much. I am touching my face with my hands too much, but my hands are sanitized. So, okay. This is floor. So I have floored that. Okay, this was not 9.98. I wanted to write 9.9, not 9 and 98. Alright, so this is floored to the previous integer, the greatest integer that is smaller than this. Okay. Next, I am going to do ceiling. Ceiling will give me the above value, right? The smallest integer that is bigger than this floating point real number. So this I have. So these are rounding function: round, floor, and ceiling. Similarly, I have trigonometric function. Let me write this degrees. Degree equal to, what are the degrees that we learned about? 0, then what, 45, 30, sorry, 45, then 60 and 90. We know what are the sine, cos and tan for this. We studied this back in school, so we will do that. Now let me convert this into radian. How do I convert degrees into radian? I multiply using np.pi, okay, using pi, and then I divide by 180. Okay, so let me print the radians, and then let me see this function, print np.degrees. Okay, this function, what does it do? It takes a it converts angle from radian to degrees. It takes a array of radians and then give you the degrees. So what are we doing here? We have taken this degree list, okay, and this is, once again I would have made a mistake. This has to be a NumPy array, not a normal Python list array. Okay, so this is the NumPy array. I am multiplying each of the value with pi and then dividing each of the value by 180. I am going to print whatever the array I get, and then I will convert it back into a degree to see that my radians are fine. Okay, so these are my radians, these are converted back into degrees. Okay, now I will print np.sine. Okay, let me not print directly, let me create variable sine equal to np.sine of rad. I have to specify degrees in radians. I next cos np.cos in radian. Then next tan np.tan in radians. So for this different degree, what did I do? I first converted those into radians, and then I am getting this sine, cos and tan for the entire array, right? Alright, it is not going to do anything. I have to print them. Print cos and then print tan. Okay, so yeah, this is my sine that is converted. Okay, this is cos. Let me show one more thing about rounding. Alright, these are two big numbers, np dot round. I am going to round it not to the nearest integer but to a floating point, but then I am going to say that I am going to round it to a floating point with two decimal numbers. Okay, what did I do? I spelled decimals incorrectly. DECIMALS. So see, this I have rounded, alright, to floats with at max 2 decimal points. So yeah, that is what I can do. These are the signs of the various degrees that I converted into radian before passing it to the sine function. These are the cos, these are the tan. Alright, I am not going to round it because I need the values to be as to have as many scientific accuracy, as many significant figures as I possibly can. Okay, so these are the sine, cos and tans of these degrees. Alright, next let me okay, you can see this is 0, this is 1 by 2, this is 1 by root 2, this is 3 by root 2, and this is 1. And then if you go from the other direction, this will be cos with lots of values inside. Okay, and if you divide this by this, you will get this time. So you can verify for yourself. Okay, next I am going to do sine inverse, cos inverse, and tan inverse. There are arc sine, arc cos, and arc tan. So I have this sine. I am going to do arc sine equal to NP dot R sine, and I am going to pass this sine function. I am going to get some values. Okay, this will be what? This sine value, if I apply the inverse, I am going to get the radians back. Okay, from this radians I got this sine, and from this sine I am going to get this radians back. But radians we are not that familiar with, so I am going to print this, convert this into degrees. Degrees are more intuitive for us. Don't know why, but this way. Alright, so let me run this. Yeah, and let me remove this for the moment. Otherwise the output gets too cluttered. Okay, so arc sine, I have given all these radians. I have given all the sine values. I got back this radians. This corresponds to the degree that we started with. So yeah, the sine and back to degree. Similarly, I have arc cos. Okay, this will give me the inverse of cos. Alright, and then arc tan. This will give me the inverse of tan. Okay, so these are about trigonometric function. We have seen arithmetic function over here. These are arithmetic functions using NP, NumPy. These are rounding functions using NumPy, and these are trigonometric function using NumPy. Right? Next, and the final thing that we are going to see is linear algebra using NumPy. Okay. This is very important. See, NumPy is used to work with matrices, right? With multidimensional array. Now, when I have this multidimensional array, of course, linear algebra is a domain where multidimensional arrays, two-dimensional matrices are used in linear algebra. Are used very much. So, it is quite natural that if I have these things, this function to do trigonometry, it should be obvious that we will have function to do linear algebra. Now linear algebra, let us go ahead and look. Let us create two matrices, A equal to NP array. I am going to create a matrix with values say 10, 11, and B equal to values say NP array. Let us first look at one-dimensional matrices. This, of course, you know, these are called vectors in the language of linear algebra. Okay, so I am going to do first the dot product. Vector dot product of A and B. Okay, what am I getting? I am getting 53, that is 10 into 2 plus 11 into 3. 10 into 2 is 20, plus 11 into 3 is 33. So 20 plus 33 is 53. So this is how I do dot product. Next, let us look at inner product, which should be similar to dot product, right? In this case, 53. If I have a two-dimensional array, multiplied with inner product with another two-dimensional array, 2, 3, say 4, 5, I am going to get this. So this is this into this. This is, I believe, this into this, right? This is this into this. What I have to verify. So this dot product, this is here. Then this dot product, this 55 plus 40 is here. Yeah. Then this dot product, this is here. This dot product, this is here. Okay. So this is your inner product result. So next, let us look at matrix multiplication. See, when we did np.multiply, or if we apply this multiplication symbol onto arrays, I am going to get what element wise multiplication. But if I need matrix multiplication, I have to use this matrix inner dot matrix. So it is very difficult to look at this array in one line, matrices in one line. So let me print it properly. I am going to do matrix multiplication of A and B. Alright. So yeah, I have this 10, 11, 12, 13, one matrix. There's 2, 3, 4, 5, another matrix. I take this, and you know what is the process to do matrix multiplication. I will get this result. Right? Okay. So this is matrix multiplication. Next, okay. Next, let us look at the way to do determinant. I am going to use this function called NumPy dot linalg, linear algebra, linalg dot det for determinant, linalg dot det, and I am going to pass the matrix, square matrix. Let's say for A, I want to find the determinant. Okay, I am going to create a new matrix. The reason is that I am going to find for A, not a problem. Okay, so this would be my determinant of this matrix, 10 into 13 minus 11 into 12, 10 into 13 minus 12 into 11. Yeah. This would be my result. But then I am going to create a three-dimensional matrix. I will show it to you. Let me 0, 2, 5. The reason I am being careful when copying this number, I am not writing this number arbitrarily. You will know why I am doing this in the next example. Let this be here. So yeah, let me find the determinant for this new matrix. So yeah, minus 21 is the determinant of this new matrix. So that is about determinant. The next topic that we are going to do is we are going to look at the inverse. And this is the reason I was being careful when writing down this matrix, because not all matrices are inversible. So if what is it called? Invertible. So if there is linear dependence between any column and the other column, then the number of pivot elements will not be equal to the dimension of the matrix in that case. we will not get the inverse of the matrix. Now there are programs that can find pseudo inverse. So if you are interested, if your application needs inverse somehow for every matrix, then you can use pseudo inverse. But then pseudo inverse is of course not inverse. And what is inverse? You will once again know what is the inverse when you go to abstract algebra in discrete maths. Like what did I tell you about identity matrix? When you multiply any matrix with its identity with the identity matrix, you will get back the same matrix. Okay. The inverse matrix is this. When you multiply a matrix with its inverse matrix, you will get the identity matrix. Okay. So let us look at the inverse of this A. This is the inverse matrix of A, right? Let me not simply print it out, but let me hold it in a variable. Let me call it I and B. Okay. So inverse, let me print it again. I am not going to see any change in the output. This is the inverse matrix of this matrix. Let me do one thing. Let me np dot matrix multiply this A with I and V. Alright. It's not important. Okay. Okay, I will issue an errata regarding this. What is the reason this is not working properly? Okay, should have worked. Okay. Let me not be stuck here. Alright. I will be addressing the issue in the description of the video. Okay. So a matrix multiplied with its inverse should have given me the what is called the identity matrix. So all the bottom elements, as I can see, are 0. All the diagonals are 1. These are as expected, but then the upper triangular matrix, my values are not correct. I don't know why. So that I will have to see what is happening. Okay. So the final thing that I am going to address now is this. Let us say I have a system of linear equation. Okay. Let me write down one linear equation. X plus y plus z equal to 6, say. Then say 2y plus 5z equal to minus 4, and then 2x plus 5y minus z equal to 27. Alright, so this is my system of linear equation. I am going to solve this system of linear equation. Okay, so let us go ahead and do it. Let me first represent. This will be represented using a matrix. This will be represented using a vector. Alright, you know this already. This is as if, let me write this in one more equation form. This is A into some x equal to this B. Right? So I have to form this x is a vector of x, y, z. So this will be a matrix. Let me create this matrix first. This is A matrix. A equal to NP dot array, and that is going to have 3 rows. In my first row I have what are the coefficient of my first row? 1, 1 and 1. Coefficient of my second row 0 to 5, 0, 2 and 5, and coefficient of the third row 2, 5, minus 1, 2, 5, minus 1. So I can see over here, this is 1, 1 and 1, this is x is not here, so it is 0, 0, 2 and 5, 2, 5 and minus 1. So these are my A matrix. Then what is my B vector? It is NP dot array. Alright, and I have these values in the vector 6, minus 4 and 27. Now with this I am ready to solve my system of linear equation. So what is the function that I am going to use? X dot linear algebra dot solve. X dot lin alg dot solve. And what are the parameters that I am going to pass? A and B. Right? So let me print X and let me run this. So I am getting this output 5, 3, minus 2. So what does that mean? That means x is equal to 5, y is equal to 3 and z is equal to minus 2. Let me verify. X plus y, 5 plus 3 is equal to 8 plus z plus minus 2. 8 minus 2 is equal to 6. Let me verify with one more. This one. 2y is equal to 6 plus 2 into 5 is equal to 10. So minus 2 into 5 is equal to minus 10. So 6 plus minus 10 is minus 4. You can verify this third equation for yourself. Alright. So this is how we solve a system of linear equation. So with this we have come to the end of this class. I hope you can see what is the importance of NumPy here. We know that linear algebra is very important, especially in fields like data analysis, machine learning, and also it is important in other fields like this affine space that we will be talking about in subjects like computer vision or image. Computer vision, image, what is the thing? I forgot the name of the subject, right? Where you work with images. Computer graphics. Yeah. So in these subjects also you need linear algebra. Then in data analysis, linear algebra is very important. So to do all this matrix operation, you have this library called NumPy. This is a very important library. Please familiarize yourself with this, work on it. If you did not understand anything, go through the this manual that I am going to provide to you. Yet I hope you have understood everything in this video. Experiment with NumPy, make changes, try for yourself, read documentation online, and of course you know how to read documentation using this help function that is available in Python. So you can use that also. I hope you have understood everything in this video. In the next video we are going to look at another module, and that is going to be the final module that we are going to look at. That would be called TK Inter. Okay, and with that we will be learning how to make GUI application using Python. So see you in the next video. If you have any doubt, you can of course WhatsApp me, you can mail me, or you can write in the comment section below. I hope you thank you for watching this video, and I hope you have understood everything. See you in the next video.